Hi there, this is MG5004 DE5418, Topic 3. This is Class 1, Part B. And if you're using your textbook, it's Chapter 7. Before we go too much further into the solution of inequalities, just go back to Topic 1 where we looked at the rules for inequality statements, and just remember that B being greater than A is the same as A being less than B. And both of them say that B is to the right of A or conversely that A is to the left of B. I will do on this slide numbers 1 and 3, and I'll do 2 and 4 on the next slide. So let's have a look at number 1 first up. So we have 3 minus 4t is less than or equal to 8 plus t. When it's like this, it's just as straightforward as solving an equation. So it gives us that negative 5 minus 4t is less than or equal to t, just using the same rules. And then negative 5 is less than or equal to 5t. So I've just added the 4t to both sides. So negative 1 is less than or equal to t. Now it's more normal to write it the other way around. Just notice which side is the biggest side, that the sort of the open mouth of the crocodile, I think you look at school. So t is greater than or equal to negative 1. And you should check that. Having a look now at number 3, where we've got t squared is greater than 9. So that means that t squared minus 9 is greater than 0. And we can factorize that. So we've got t plus 3 times t minus 3, because it's the difference of two squares, is greater than 0. Now, if two numbers multiply together to make a positive number, either the two numbers are positive or the two numbers are negative. So let's take the positive case. So either t plus 3 is greater than 0 and t minus 3 is greater than 0, because that gives us a positive answer. So that gives us that t is greater than negative 3 and t is greater than 3. Now these are both true only when t is greater than 3. So you've got to have them both true. Or, looking at the other side, t squared is greater than 9 when t plus 3 is less than 0 and t minus 3 is less than 0. So that gives us that t is less than negative 3 and t is less than 3. So these are both true only when t is less than negative 3. So our solution then to our original problem is that it's t squared is greater than 9 when t is greater than 3 or when t is less than negative 3. And you should check. If we've got a fraction that's positive, then to get a fraction it must be a division sum. So if the fraction is positive, then the top line and the bottom line must be positive. So that's maybe case A. Oops. drawing too close to the edge. So case A, if they're both positive, then that will give us a positive fraction, or if they were both negative, we would still get a positive fraction. Like that. So let's have a look at case A. So if t plus 1 is positive, then that will give us that t is greater than negative 1. And if 3t minus 6 is positive, then t is going to be greater than 2. Now both of these are only true when t is greater than 2. For case B, if t plus 1 is negative, then t is less than negative 1. And if 3t minus 6 is negative, then t is less than 2. And both of these are only true when t is less than negative 1. So overall, the fraction is positive when t is greater than 2 or when t is less than negative 1. Let's change question 4 slightly so that it's y squared minus 3y minus 10 is greater than or equal to 0. So we can factorize that to y minus 5 and y plus 2, and it's still greater than or equal to 0. Let's have two cases. We kind of proceed as if it's an equality, but not quite. If we need both of them to be positive, and that will give us a positive answer, then y would be greater than or equal to 5, and y would be greater than or equal to negative 2, and the combination of those would give us that y was greater than or equal to 5. And case B, if both of the brackets were negative, then that would give us that y was less than or equal to 5 and y was less than or equal to negative 2, and the combination of those would give us that they were both true when y was less than negative 2. So those two answers combined would give us that, well, we couldn't write it any other way. We can't write it as a combination statement. But if we look at the graph, now it's a parabola, it's going to cut through 5 and negative 2 and negative 10. So it's going to be something like that. Looking at that, the positive bits are these bits here. This is where the function is positive. That is where y is greater than or equal to 0. So you can quite clearly see there our answers are correct, that y, that's the y, is greater than or equal to 5 and y is less than or equal to negative 2. Let's pretend we can't see the solution yet, and we're looking to solve absolute value of 5x minus 2 is less than 4. Now you remember from the definition of the absolute value of x is equal to x if x is positive, and it's equal to the opposite of x if x is negative. Now it's not just x, it's the bit in there. So that's the bit in there, bit in between the modulus signs, and the same in here. So it's the opposite of that. So in this case, if we've got the first part of the definition, then 5x minus 2 is going to equal 5x minus 2 if the bit in between the modulus signs is 5x minus 2 is positive. And that's going to give us, if we play around with that, that in putting it back into here as well, then 5x minus 2 is going to be less than 4, which tells us that x is less than 6 over 5. And if we look at part 2, that if the bit is negative, then what we've got now is that 5x minus 2 is equal to the opposite of 5x minus 2. Remember, we tried to solve for where that is less than 4. So that gives us that negative 5x plus 2 is less than 4. So negative 5x is less than 2. So that x is less than, no, x is now greater than, because we're dividing by a negative number, x is greater than negative 2 over 5. Now, can we put those together in one statement? I think we can. We can say that negative 2 over 5 is less than x, which is less than 6 over 5. Now, that is shown on the number line above. It's less than in each case, so the circle, the little circle on the numbers is an open circle, and the answer falls somewhere between negative 2/5 and 6/5. We can solve inequalities directly from the graph. I've drawn there y equals 5x plus 2, and suppose we wanted to solve 5x plus 2 is positive, then just doing it, make it positive. Then using the normal method, 5x is greater than or equal to negative 2, so x is greater than or equal to negative 2/5. And if we look at the graph, indeed, that is the case. So from here upwards, y is positive. And that's what we wanted. We wanted 5x plus 2 to be positive. So all of this bit is the bit that we were looking for, and that occurs anytime x is greater than or equal to negative 2/5. Looking at this curve, this is a quadratic. The function, which is the y value, is going to be negative below the x-axis. So we're cutting the x-axis at 3 and negative 2. So if we wanted y to be negative, then it's going to be where x is between negative 2 and 3. And we can write that in the single statement. We would say that negative 2 is less than x, which is less than 3, will give us negative values of y. Later on in the course, we'll be looking at finding the area between curves and the x-axis. So maybe we wanted to find the area in here. And in order to do that, we need to find these 4 intercepts. Now, it's not that easy. Perhaps you've used Desmos or some other graphical software. Let's go ahead and tell us that when y is equal to 0, we've found that x equals negative 2.5, x equals negative 1, x equals 1.5 and x equals 2.2. Okay, so we've used Desmos or something to find those values. Now we can tell by looking at the graph that the negative bits are the bits below the x-axis. So what we need to be dealing with, this is later in the course, but for the moment, the part where y is negative, or maybe we'll just do less than, would be the bit between -2 and -1, which we would write as -2.5 is less than x, which is less than -1. And the right-hand side, which is where 1.5 is less than x, which is less than 2.2.